The climate of Antarctica is the coldest on Earth. Antarctica has the lowest naturally occurring temperature ever recorded on the surface of the Earth, an 89.2 degrees Celsius at Vostok Station. Satellites have recorded even lower temperatures, down to -93.2 degrees Celsius. It is also extremely dry, averaging 166 millimeters of precipitation per year. On most parts of the continent the snow rarely melts and is eventually compressed to become the glacial ice that makes up the ice sheet. Weather fronts rarely penetrate far into the continent, because of the Katabatic winds. Most of Antarctica has an ice-cap climate with very cold, generally extremely dry weather. Temperature: the lowest reliably measured temperature of a continuously occupied station on Earth of 89.2 degrees Celsius was on July 20, 1983 at Vostok Station. For comparison, this is 10.7 degrees Celsius colder than subliming dry ice. The altitude of the location is 3,900 meters. The lowest recorded temperature of any location on Earth's surface was a 93.2 degrees Celsius at 81.8 degrees 59.3 degree/-81.8. 59.3, which is on an unnamed Antarctic plateau between Dome A and Dome F, on August 10, 2010. The temperature was deduced from radiance measured by the Landsat 8 satellite, and discovered during a National Snow and Ice Data Center review of stored data in December, 2013. This temperature is not directly comparable to the -89.2 quoted above, since it is a skin temperature deduced from satellite-measured upwelling radiance, rather than a thermometer-measured temperature of the air 1.5 m above the ground surface. The highest temperature ever recorded in Antarctica was 14.5 degrees Celsius in two places, Hope Bay and Vostok Station, on January 5, 1974. The mean annual temperature of the interior is of 57 degrees Celsius. The coast is warmer. Monthly means at McMurdo Station range from a 26 degrees Celsius in August to a 3 degrees Celsius in January. At the South Pole, the highest temperature ever recorded was a 12.3 degrees Celsius on December 25, 2011. Along the Antarctic Peninsula, temperatures as high as 15 degrees Celsius have been recorded, though the summer temperature is below 0 degrees Celsius most of the time. Severe low temperatures vary with latitude, elevation, and distance from the ocean. East Antarctica is colder than West Antarctica because of its higher elevation. The Antarctic Peninsula has the most moderate climate. Higher temperatures occur in January along the coast and average slightly below freezing. Precipitation: the total precipitation on Antarctica, averaged over the entire continent, is about 166 mm per year. The actual rates vary widely, from high values over the peninsula to very low values per year, in the high interior. Areas that receive less than 250 mm of precipitation per year are classified as deserts. Almost all Antarctic precipitation falls as snow. Note that the quoted precipitation is a measure of its equivalence to water, rather than being the actual depth of snow. The air in Antarctica is also very dry. The low temperatures result in a very low absolute humidity, which means that dry skin and cracked lips are a continual problem for scientists and expeditioners working in the continent. Weather condition classification: the weather in Antarctica can be highly variable, and the weather conditions can often change dramatically in short periods of time. There are various classifications for describing weather conditions in Antarctica. Restrictions given to workers during the different conditions vary by station and nation. See Antarctica Weather Danger Classification. Ice cover: nearly all of Antarctica is covered by a sheet of ice that is, on average, a mile thick or more. Antarctica contains 90% of the world's ice and more than 70% of its fresh water. If all the land ice covering Antarctica were to melt around 30 million cubic kilometers of ice the seas would rise by over 60 meters. This is, however, very unlikely within the next few centuries. The Antarctic is so cold that even with increases of a few degrees, temperatures would generally remain below the melting point of ice. Warmer temperatures are expected to lead to more snow, which would increase the amount of ice in Antarctica, offsetting approximately one-third of the expected sea level rise from thermal expansion of the oceans. During a recent decade, East Antarctica thickened at an average rate of about 1.8 centimeters per year, while West Antarctica showed an overall thinning of 0.9 centimeters per year. For the contribution of Antarctica to present and future sea level change, see sea level rise. Because ice flows, albeit slowly, the ice within the ice sheet is younger than the age of the sheet itself. Ice shelves. Most of the coastline of Antarctica is ice shelves or ice walls. Melting or breakup of floating shelf ice does not affect global sea levels, and happens regularly as shelves grow. Known changes in coastline ice, around the Antarctic Peninsula, 1936–1989, were the ice shelf significantly reduced in size. 1995, Prince Gustav Channel no longer blocked by ice. Last opened from about 1900 years ago to 6500 years ago, probably due to warmth during the Holocene climatic optimum. Parts of the Larsen ice shelf broke up in recent decades. 1995, the Larsen A ice shelf disintegrated in January 1995. 2001, 3,250 km² of the Larsen B ice shelf disintegrated in February 2001. It had been gradually retreating before the breakup event. The George VI ice shelf, which may be on the brink of instability, has probably existed for approximately 8,000 years, after melting 1,500 years earlier. Warm ocean currents may have been the cause of the melting. The idea that it was warmer in Antarctica 10,000 years ago is supported by ice cores, though the timing is not quite right. Climate change. The continent-wide average surface temperature trend of Antarctica is positive and significant at greater than 0.05 AA degrees Celsius decades since 1957. The West Antarctic ice sheet has warmed by more than 0.1 AA degrees Celsius decade in the last 50 years, and is strongest in winter and spring. Although this is partly offset by full cooling in East Antarctica, this effect is restricted to the 1980s and 1990s. Research published in 2009 found that overall the continent had become warmer since the 1950s, a finding consistent with the influence of man-made climate change. We can't pin it down, but it certainly is consistent with the influence of greenhouse gases from fossil fuels, said NASA scientist Drew Shindell, another study co-author. Some of the effects also could be natural variability, he said. The British Antarctic Survey, which has undertaken the majority of Britain's scientific research in the area, has the following positions. 1. Ice makes polar climate sensitive by introducing a strong positive feedback loop. Melting of continental Antarctic ice could contribute to global sea level rise. Climate models predict more snowfall than ice melting during the next 50 years, but models are not good enough for them to be confident about the prediction. Antarctica seems to be both warming around the edges and cooling at the center at the same time. Thus it is not possible to say whether it is warming or cooling overall. There is no evidence for a decline in overall Antarctic sea ice extent. The central and southern parts of the west coast of the Antarctic Peninsula have warmed by nearly 3 AA degrees Celsius. The cause is not known. Changes have occurred in the upper atmosphere over Antarctica. The area of strongest cooling appears at the South Pole, and the region of strongest warming lies along the Antarctic Peninsula. A possible explanation is that loss of UV-absorbing ozone may have cooled the stratosphere and strengthened the polar vortex, a pattern of spinning winds around the South Pole. The vortex acts like an atmospheric barrier, preventing warmer, coastal air from moving into the continent's interior. A stronger polar vortex might explain the cooling trend in the interior of Antarctica. 2. In their latest study, NASA researchers have confirmed that Antarctic snow is melting farther inland from the coast over time, melting at higher altitudes than ever and increasingly melting on Antarctica's largest ice shelf. There is also evidence for widespread glacier retreat around the Antarctic Peninsula. Researchers reported December 21, 2012 in Nature Geoscience that from 1958 to 2010, the average temperature at the mile-high bird station rose by 2.4 degrees Celsius, with warming fastest in its winter and spring. The spot, which is in the heart of the West Antarctic ice sheet, is one of the fastest warming places on Earth. See also, Antarctica cooling controversy, climate of the Arctic, effects of global warming, retreat of glaciers since 1850, polar amplification, references. Notes, D. G. Vaughan, G. J. Marshall, W. M. Connolly, J. C. King, and R. M. Mulvaney. Devil in the Detail. Science 293, 1777 Euro 9 doi, 10.1126/Science 1065116. PMIDA 11546858 M. J. Bentley, D. A. Hodgson, D. E. Sugden, S. J. Roberts, J. A. Smith, M. J. Leng, C. Bryant. Early Holocene retreat of the George VI ice shelf, Antarctic Peninsula. Geology 33, 173 Euro 6. Bibcode, 2005 Geo, 33173b doi, 10.1130 per gram 21203.1 External links, Climate data from Antarctic surface stations with trends, temperature data from the Reader Project, a pamphlet about the weather and climate of Antarctica, information concerning recent ice shelf carving, unreliable, maps of snowfall and temperature statistics at the Amundsen-Scott Station on the South Pole, warmer temperatures, more snow. Australian Academy of Science, Antarctica's central ice cap grows while glaciers melt, AWS and AMRC real-time weather observations and data. University of Wisconsin-Madison's Antarctic Weather Stations Project and Antarctic Meteorological Research Center. Retrieved May 31, 2005. Antarctica Climate and Weather, Climate Change in Antarctica, http www.antarctica.ac.uk Climate Change Position HTML, http www.antarctica.ac.uk Ice Sheet Sea Level Ice Shelf Loss HTML, Western Antarctica Warming Confirmed December 23, 2012 USA Today, Antarctic Ice, Sea Ice Index Trends in Extent Southern Hemisphere. National Snow and Ice Data Center. Retrieved January 9, 2009 Coastal Change and Glaciological Maps of Antarctica. USGS Fact Sheet 2005 3055. Retrieved May 31, 2005 Coastal Change and Glaciological Maps of Antarctica. USGS Fact Sheet 050 98. Retrieved February 28, 2005 Coastal Change and Glaciological Map of the Yates Coast Area, Antarctica. 1972 2001. U.S. Geological Survey Scientific Investigations Series Map, I-2600E. Retrieved February 28, 2005 Coastal Change and Glaciological Map of the Bakutis Coast Area, Antarctica. 1972 2002. U.S. Geological Survey Scientific Investigations Series Map, I-2600F. Retrieved February 28, 2005 Coastal Change and Glaciological Map of the Saunders Coast Area, Antarctica. 1972 1997. U.S. Geological Survey Scientific Investigations Series Map, I-2600G. Retrieved February 28, 2005 A. Satellite Image Atlas of Glaciers of the World Antarctica. U.S. Geological Survey Professional Paper 1386b. Retrieved February 28, 2005 Further reading, warm snap turned Antarctica green around the edges. Thawed-out continent was lined with trees 15 million years ago, study says. June 20, 2012 National Geographic, taking Antarctica's temperature. Frozen continent may not be immune to global warming July 27, 2013. Volume 184 Number 2 Science News.